Okay, the last couple of problems. Here we're going to be working forwards and backwards. Here we have a vertical asymptote at x equals -2, a horizontal at 4, and a removable discontinuity at 1. The way I like to start is by making my fraction, and then I always start with that removable discontinuity if there is one. To have a removable discontinuity at 1, that means that's what I need to have x minus 1 in the numerator and in the denominator. I like to stack them the way that I would see it right before I cancel them. Okay, the next thing I want to make sure I take note of is this vertical asymptote. To have a vertical asymptote at -2, that means I need my denominator to have x plus 2 in it. And a horizontal asymptote at 4, so since it's other than 0, that means since it's y equals a number, that means I need the same degree on the top and bottom. And I need that ratio of those leading coefficients to be 4. Right now I have one x in the top and 2 in the bottom, so I need another x on top. And you can make it like that is going to give us a 0 of x equals 0. You can make that, make it a little x minus 2. As long as it doesn't cancel the x plus 2, you're good. And then I need same degree, and I need my leading coefficients to be 4 over 1. So I would do that directly there, 4 over 1. You could also make it 8 over 2 or 16 over 4. Just make sure you don't throw a negative in there. The only thing that we created that wasn't in that problem is that we made this guy. That would give us a 0 or an x-intercept at x equals 0. Everything else was asked for in that problem. So I would just kind of do it in pieces like that and check them off as you get them done. All right, vertical asymptote at x equals 5 and a slant asymptote. Okay, to have that vertical asymptote at x equals 5, that means we need x minus 5 in our denominator. And now there are two ways you can get this slant asymptote going at 2x minus 3. The first way, and you can pick the way you like, the first way is by multiplication. The second way is kind of by backwards synthetic division. Either way works, you just have to be careful. So if you're going to do multiplication, what you would do, since usually to find the slant asymptote, we divide by our vertical asymptote. So to undo that, you would multiply. Multiply out 2x minus 3 times our little vertical asymptote, x minus 5. So 2x squared minus 10x minus 3x minus 15. Now here's what you have to make sure you do though. This, it can't come out even. If it comes out even, you would be able to cancel the x minus 5, and then you would have a whole and not an asymptote. So when you combine your like terms here, you're going to make this 2x squared minus 13x. That's lovely. Now, just don't make this factorable. And to not make that factorable, you're going to change that 15 to something else. Minus 14. Make it minus 1. It doesn't matter. So you're just doing that division backwards. And how do you undo division? You multiply. The other way that you can tackle that is by backwards synthetic division. So our asymptote is at 5. We want 2x minus 3. And again, we don't care what that remainder is. So how would you make this happen? Well, how would you get 2 and negative 3 out of this synthetic division? Well, that would have to be a 2, because you always bring that first number down. 5 times 2 is 10. Okay, what plus 10 gives you negative 3? Negative 13. And you should see like, oh yeah, that's what we got for our middle term when we did that multiplication. And then you just have to make sure 5 times negative 3 is negative 15, so you would need this to come out with a remainder. So if you make that 14, that ends up being negative 1, and that's lovely, or negative 14, that ends up being not 0. So Either way, you're going to get something nice, something that works, as long as you make sure, one, your synthetic division doesn't work out to be a zero remainder, or that you change that constant in your last, in your multiplication. So that's how you get that slant asymptote to happen. And of course, you can double check that on your calculator and make sure that your problem comes out the way you want. Okay, new problem for this year. We're going to have a vertical asymptote at x equals 0 and at x equals -7. We're going to have a horizontal asymptote of y equals 0. And we're going to have an x-intercept. We're going to throw x-intercept in here. How about 3, 0? Okay, see if you can build that after watching the last two videos, and go ahead and pause, see if you can build that, and then come back and I will help you out if you need to. Okay, hopefully you got something down. I'm going to do this again by pieces. For x equals 0, there are two ways you can write that. You could write that just as x minus 0 in your denominator. That's lovely. Or the way you see it usually written in a problem is just a single x. So that's one of our vertical asymptotes. The other one here is x minus 7, or x equals -7, so that'd be x plus 7. Denominator taken care of so far. Let's jump down to our x-intercept. I know we need that. To have an x-intercept at 3, 0, that means in my numerator, I need to have x minus 3. So remember, x-intercepts come from our numerator. And then for our horizontal asymptote of y equals 0, we just need our fraction to be bottom heavy. And it turns out, it already is. So you don't have to add anything. You could add whatever coefficients you wanted. You could put a 4 in front of the numerator or in front of the x in the denominator, and it would not change that that's bottom heavy and that you are your asymptote, your horizontal asymptote at y equals 0. Okay, I hope this review was helpful. Please see me if you have any additional questions or if you need some more practice before the test.